Imagine a strange, mysterious object racing through space at a speed greater than that of a typical comet. This is not the plot of a science fiction story, but a reality observed by astronomers in 2017. At that time, an object was detected in the depths of the universe that would go down in history as the first interstellar traveler to visit our solar system. But what message did this mysterious visitor bring? Barely visible, as if emerging from the depths of space, it burst into our solar system, shattering familiar ideas about how celestial bodies should behave. Scientists watched it closely, expecting to see a bright tail of gas and dust, like other comets. Yet the traveler seemed to hide its intentions. Its path was clear, without any signs of emissions. Since then, theories and hypotheses have emerged one after another. Could this object be more than just an unusual celestial body, possibly even an artificial probe launched by an unknown civilization? Or is it a new type of cosmic object that science has yet to explain? What lies behind this silent mystery from the depths of interstellar space? In 2017, a landmark event occurred in astronomy. The first interstellar object passing through our solar system was detected. This object, named Oumuamua, became a true sensation due to its characteristics, which differed radically from all previously known objects. The object was discovered on an extremely high hyperbolic orbit by Robert Werik on October 19, 2017, based on data from the Pan-STARRS telescope when the asteroid was 30 million kilometers from Earth. The name Oumuamua in Hawaiian means scout or messenger from afar, perfectly reflecting the uniqueness of this visitor arriving from the depths of space. On October 26, 2017, one I/Oumuamua was found in two additional observations made on October 14 and 17, 2017, obtained from the Catalina Sky Survey, one of the 3 surveys that are part of the Catalina Sky Survey Consortium. The primary goal of this consortium is to identify 90% of near-Earth asteroids larger than 140 meters. About a week later, Oumuamua was noticed by Robert Werik, a Canadian astronomer and physicist. The object passed its perihelion, the closest point to the Sun, more than a month before its discovery, coming within 0.25 astronomical units of our star. Oumuamua entered our system approaching the Sun at a speed of 26 kilometers per s, and then shot away from it at nearly 88 kilometers per s. Even the Hubble Space Telescope lost the ability to observe it after January 2018. Between October and January, there was a real rush among astronomers to conduct as many observations of Oumuamua as possible using telescopes. However, what kind of message could it have brought from deep space? Was its appearance here coincidental, or does it indicate the existence of yet-to-be-explored types of objects passing by us? After the discovery of Oumuamua, scientists began intensive research into its unique characteristics, which immediately set it apart from known celestial objects. In addition to its unusual shape, combining features of both a cigar and a pancake, its brightness fluctuated by more than 10 times. These variations allowed astronomers to suggest that its length ranges from 100 to 400 meters, with it being elongated roughly 6 to 10 times longer than its width. Such an extremely elongated body had not been observed within our solar system before. Even if we managed to find a similarly shaped object, explaining its origin within the framework of conventional models of solar system formation would be exceedingly difficult. Moreover, the surface of Oumuamua has a reddish color, which adds to its mystery. This hue is characteristic of certain groups of bodies in our system, such as D-class asteroids and trans-Neptunian objects. However, the color provides little information about the composition of this object, as the reddish tint can arise from various factors. One theory posits the presence of tholins, organic compounds found on the surfaces of other celestial bodies such as Arakoth. Another possibility is the presence of iron deposits, similar to those on the surface of Mars. It is also plausible that the red color is a result of space weathering, where micrometeorites and sunlight alter the surface properties of the body, giving it specific shades. The absence of a coma and tail in Oumuamua also distinguishes it from most comets, which typically emit water and molecules when heated, creating a characteristic glowing halo. However, Oumuamua was too small and too far from the Sun to possess a significant amount of water for such an outgassing. All this forced scientists to re-evaluate conventional theories, attempting to understand how this strange and unique object could have formed and how it ended up within our system. Could Oumuamua represent the first member of a new class of interstellar objects? Or are we witnessing evidence of processes occurring in the depths of space that are beyond our comprehension? One of the most intriguing mysteries associated with Oumuamua is its anomalous acceleration as it moves away from the Sun. The motion of objects in space generally follows the laws of celestial mechanics and gravity. The farther an object is from the Sun, the slower it moves due to decreasing gravitational pull. However, in the case of Oumuamua, this principle seemed to be violated. Its acceleration is directed away from the Sun, and its strength diminishes as the distance between the object and the star increases. Karen Meach, an astronomer, proposed several possible explanations for this phenomenon. A team of scientists investigated 8 hypotheses, including resistance, gravitational interaction with other bodies, a strong magnetic field, and the impact of solar radiation. As the analysis progressed, these options were systematically ruled out. For example, friction or resistance would likely pull Oumuamua toward the Sun rather than push it away. No significant objects were detected in its path that could have influenced its motion. Even a hypothetical strong magnetic field of the object would not explain the observed acceleration when interacting with the solar wind. For solar photons to have a noticeable impact on Oumuamua's trajectory, the object would need to be extraordinarily light, with a density comparable to that of aerogel. Scientists from the Harvard-Smithsonian Center for Astrophysics, Shmuel Bayali and Abraham Loeb, suggested that Oumuamua might be a thin object with a large surface area, similar to a solar sail. This assumption would account for its acceleration, caused by the pressure of sunlight. Researchers observed Oumuamua for 30 hours using the Spitzer Space Telescope, but found nothing. This was strange because a significant outgassing was expected. Otherwise, where would the acceleration come from? Despite precise measurements, no traces of cyanide or any other gases were detected. When gas escapes from a comet, it typically carries dust from the surface with it. The stronger the gas outflow, the more dust it picks up. Such unusual acceleration without visible causes raised questions about the nature of Oumuamua itself. Is it a natural object, or do its properties indicate something more mysterious? Perhaps it is evidence of unique processes occurring in interstellar space that are yet to be studied. In an attempt to explain the unusual properties and behavior of Oumuamua, researchers have proposed various hypotheses. Several years have passed since the first observation of the mysterious object, Oumuamua, yet its origin and nature remain subjects of debate among scientists. Initially, it was classified as a comet, but further observations revealed no signs of cometary activity, leading to its quick reclassification as an asteroid. Recently, the scientific community presented another version. According to an article in the AGU Journal of Geophysical Research, Oumuamua may be a fragment of an exoplanet rich in nitrogen ice that was ejected from its surface due to a Pluto-like destruction event. However, there is an even more unusual hypothesis. Some astronomers suggest that Oumuamua is not merely a random fragment of cosmic material. It may have been sent by an extraterrestrial civilization and represents a kind of space probe. But could this really be an interstellar ship created by unknown beings? Among the proponents of this version is Avi Loeb, a renowned astronomer and professor at Harvard University, who sees it as a logical explanation. Applying Occam's razor, he argues that this hypothesis is the simplest and most convincing. All other theories require the acceptance of highly unlikely scenarios. For instance, the possibility of such an unusual shape arising in an interstellar hydrogen cloud or an incredibly rare type of planetary debris seems less probable to him than the idea of artificial origin. In his book Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, Loeb recounts the story of the discovery of Oumuamua, its mysterious properties, and presents arguments for its artificial origin. Such theories often sound like attempts to attract attention, but the scientist emphasizes that this hypothesis should be approached without bias. There were no recorded signs of dispersing particles of dust and gas from this object, which excludes its classification as a comet. However, its trajectory displays anomalous acceleration that cannot be explained by gravity. Another intriguing fact is that the trajectory calculations of Oumuamua showed that before entering the solar system, it seemed to be waiting in place, moving at minimal speed relative to the interstellar medium. It is possible that it was left behind by another civilization, waiting for its moment to activate and begin studying the nearest star system. However, in mid-2019, a number of astronomers declared that there is no evidence supporting its artificial origin. So, could Oumuamua's nature be the result of natural processes yet to be explored by humanity? Despite the excitement surrounding the hypothesis of an extraterrestrial origin for Oumuamua, most scientists lean toward a more conservative explanation of its characteristics. The discovery of this object marked an important milestone in astronomy, as it was the first time researchers could confirm that interstellar objects can indeed penetrate our solar system. Oumuamua became a messenger from another corner of the galaxy, evidence that our star system does not exist in isolation, but is part of a larger interstellar flow that carries traces of other stellar systems and possibly their histories. Oumuamua's presence in our solar system indicated the possibility of many other objects that could be entering our stellar region unnoticed. Previously, such interstellar travelers were merely a theoretical possibility, but now, thanks to Oumuamua, scientists have realized that similar bodies are likely entering our vicinity much more frequently than previously thought. The discovery of Oumuamua served as a catalyst for the development of new methods and technologies capable of detecting and studying such objects at early stages of their approach to the solar system. Furthermore, understanding the nature of such objects can provide valuable insights into the processes occurring in other stellar systems. Interstellar bodies like Oumuamua potentially contain traces of conditions that existed in their home systems, and may even hold building blocks for life if they originated from regions with suitable chemical conditions. Will the next step be the development of new missions and projects for a deeper exploration of these cosmic wanderers to uncover the mysteries of their origins and chemical compositions? The discovery of Oumuamua inspired the European Space Agency, ESA, to develop new missions aimed at exploring interstellar objects. One such initiative is the mission called Comet Interceptor, which will be an important step in studying objects beyond the solar system. Comet Interceptor is a unique spacecraft developed by the European Space Agency, with a launch planned for 2029. It will be positioned at the L2 Lagrange point of the Sun-Earth system, approximately 1.5 million kilometers from our planet. This is a special region in space where the gravitational forces of the Earth, Sun, and Moon are balanced, allowing the spacecraft to hover and wait for its target. What makes this mission unique? Why is Comet Interceptor going into space without knowing its target in advance? What discoveries await us at the edge of the solar system? And what secret visitor from the depths of space could become its first target? A distinctive feature of the Comet Interceptor mission is that this spacecraft will launch into space even before a specific target is chosen for it. Scientists are particularly interested in comets that are visiting us for the first time from the Oort cloud, a distant region surrounding the solar system, believed to contain frozen fragments of the material from which planets and stars formed. These comets have not yet lost their material due to solar heat and may contain unique traces from the early era of our Sun. However, the scientists' ambitions do not end there. They hope that the mission could intercept an object from another star system, similar to Comet Borisov, the first interstellar comet, with a heliocentric orbital eccentricity epsilon 3. The very interstellar traveler that has already visited us once. If such a guest can be captured, researchers will have the chance to glimpse material that formed in other worlds for the first time. But these comets and interstellar objects approach the Sun quickly and depart just as rapidly, leaving our system forever. Waiting on Earth and trying to chase such a target would be futile. There is no time for preparation. That is why Comet Interceptor will be sent into space in advance, moving to a safe distance from Earth and taking its position. There, in a state of gravitational equilibrium, the spacecraft will be able to hover and wait for fate to bring it together with a long-awaited visitor from distant corners of space. Will the results of this mission shed light on the mysteries of interstellar travelers like Oumuamua? And will they help scientists better understand the secrets that these cosmic messengers hold? The Comet Interceptor mission marks the beginning of a new era in astronomy, as its success could unlock entirely new opportunities for studying interstellar objects. Oumuamua provided scientists with a unique opportunity to realize that our solar system does not exist in a vacuum. It is surrounded by a flow of celestial bodies that may carry important data about other star systems and possibly even about the processes leading to the formation of life. Future missions to explore interstellar objects may include the use of more powerful telescopes and probes with advanced navigation and analysis capabilities. For instance, next-generation large telescopes like the Large Synoptic Survey Telescope, LSST, in Chile promise to enhance our ability to detect such objects. LSST is expected to begin full operations in August 2025 and will become an important tool for detecting interstellar bodies in the early stages of their entry into the solar system. This will enable astronomers to respond more quickly to such events and plan observations with respect to the expected timeframes of their stay in our system. Over time, astronomers hope to develop technologies that will allow missions to interstellar objects to be launched in shorter timeframes and eventually even land on these bodies for sample collection. With advanced analytical tools, it may not only be possible to study the composition of these objects, but also to potentially find chemical elements or molecules that could shed light on the origins and evolution of other planetary systems. Thus, Oumuamua has not only inspired the launch of new missions, but has also laid the groundwork for future breakthroughs in astronomy and astrophysics. This means that the future of interstellar object exploration promises to be exciting and full of new discoveries. Subscribe to the channel, stay updated on the news, and keep track of all the latest achievements in science.